as you start looking at the chapter itself, there's only one thing that you guys hadn't worked on yet, the quiz stuff. The quiz that we had went up through 1-3, and then after that was just angles. So what I want to do is kind of remind you guys a little bit of each of the individual sections as far as things that we talked about, things that we worked on, things that I know you're still messing up on, and kind of help you with that. I do have some review problems for you guys to do later, and then we'll go through all. One of the things that we first started out in 1.1, what this section really was all about diagrams and labels and how do you draw stuff. Things like that. For example, one of the first things we talked about drawing was line AB. If I wanted to draw and label line AB, well, I'd have to put 2 points, draw through it, throw a couple arrows, and make a line AB. What's another name for that line? BA. Going forward and backwards, the same thing for lines. It's okay. Now, what was the other way that you could also draw or label a line? What's another way you could also label a line? Remember? There was another way, bless you, that we were able to label a line. No. Remember when you did this, lowercase cursive? That's another way that you can see a line. Lines are also written sometimes as lowercase cursive letters. Okay. It's not as common, but it does show up from time to time. Okay. When you had lines or line segments, did the order matter? I know you just said that earlier. Line BA is the same thing as line AB. The order doesn't matter, it's in segments. The segment, remember, is a measured distance of a line. It's something you can actually measure itself out to. What does matter is when you start talking about rays. If it's ray x, y, what's important about x?
X has to be the endpoint. X has to be the endpoint.
Pull your phone out of there, put it away. Okay. I'm sorry, go ahead.
X has to be the endpoint.
Yeah, x is the endpoint. Now, does it matter if it was written like this? Oops. It's still the endpoint. The endpoint is always the one that doesn't have the arrow on it. It just means there's x, and it goes through y. That's all. That's all that meant with rays. Okay. What did two rays that shared a common endpoint? Oh, I'm sorry. What do opposite rays make? A door? I know. They make lines. Opposite rays create lines. Opposite rays, remember we had that question on the quiz like that? I think it was ray AB and ray AC. They were opposite rays. Opposite rays create lines. Opposite rays create lines. Opposite rays create lines. What else was there? Planes. How many points do you need to make a plane? How many? 1? 4? 6? How many? Yes, sir. 3. Planes. You need 3 points to make a plane. More specifically, they have to be 3 non-collinear points. Remember non-collinear? What was that? Not on the same line, very good. 3 non-collinear points create a plane. When you label planes, you only use capital letters again. So let's say this is A, B, C. I could call that plane ABC, BAC, CAB, BCA. Any one of those works. It's just 3 non-collinear points. Okay. If I happen to have, what's another way that sometimes planes are written out besides 3 capital letters? Remember that one? Capital cursive, excellent. Sometimes planes are written out as a capital cursive letter. And it wasn't a very fancy R, but you can squint and it might look like it's capital cursive to you.
No, mine just looks blurry.
Anyway, so yeah, that was with the planes. The intersection of 2 planes create a what? No. The intersection of 2 planes create what? I see a bunch of them in this room.
Oh.
Not necessarily.
Perpendicular.
Not necessarily. Think about what a plane is. Remember, a plane is a flat surface that extends infinitely in 2 directions? If 2 planes intersect, we think about where the ceiling hits the wall. That crease, it's a line. It's a line. Intersection of planes create lines. Okay? Intersection of planes create lines.
Wait.
What else was there in that one that was weird? That's about it. Because then once we started getting, after that, we started talking more and more about segments. And segments is where things got interesting. As we got into segments, as we started talking about these, segment XY was some measured distance. That meant that if I had XY and I put some other point in between it somewhere, if I said that the whole thing was 16 and this chunk was 5, what were you able to do then to find out the other chunk? Subtract it. Because what we did is we started talking about what's called segment addition. Yeah, segment addition. 2 smaller chunks add up to equal the larger. If you have collinear points, if they're all on the same line, you're able to do this stuff without a problem. You're just adding things together. And just like you said, you did 16 subtract the 5, and it gave you the 11 for there. Which meant that we got to do a ton of algebra. The algebra was never anything real crazy or scary or anything like that. It was just a matter of a quick setup, draw a picture, and solve. For example, point B is between A and C on segment AC. When you read directions that looks like that, point B is between A and C on segment AC, that just means that all 3 of those points are collinear. So what do you think you would do to set up a problem like this? Draw a picture. Yep, just draw a picture. Draw and label. And we fill in the blanks. That much was 8. The whole thing was x plus 18. And this much was 2x plus 18. Because that's what the problem means. B is between it, 2 smaller chunks add up equal to large. And you're back to a combined like terms equation. We know that AB plus BC has to equal the whole thing, so we write it out. Okay. Combine your like terms. What's 8 and 18? Very good. Okay. Variables on both sides of the equation. Who are you going to pick on? The little guy. You're going to pick on the x or the 2x? X. So I'll subtract x. At the same time, I'm going to move the 26 by subtraction as well. I get x equals negative 8. What? Wait a second. Can you get a negative number for an x? Yes. Because are the segments negative? Value okay for negative. Because if you substitute back in, what's negative 8 plus 18? It's 10. Well, if I substitute here, we should double check, make sure that if this much is 8, this much should be equal to 2 then. Well, that's negative 16. What's negative 16 and 18? 2. So it is okay that you get a negative for an x, but it's not the segment itself that's negative. Okay? Does that make sense? Because you can't measure a negative distance, but you can have a negative x. That was the same thing that we talked about with angles. You could get an x value when you solve out an equation that has a negative, but the angle won't be negative. Well, next year, you can have negative angles. No, but I'm serious. This is really, really easy. Trust me on this. When you have a negative angle, there's no marker here. Go all the way back here. When you start worrying about angles and stuff like that in Algebra 2, we measure stuff, we go counterclockwise, like that. That's a positive angle. So if I say an angle is 200 degrees, I would mark it, and it would be right here, okay? Because this starts at 0, that's 180, and just drop it down a little bit further. If I say that an angle is negative 200 degrees, for other example, that just means I go the other direction. So instead of going counterclockwise, I go clockwise. I would do stuff like that. I just spin the other way. That's all. So it's not that it's going to be scary, freaky, difficult to work with. It just needs a different direction. That's all. But like I said, you won't need to worry about that at all this year. So you got that going for you. Let's make this land down there. Oh, well, at least it's marked with that now.
If my kids ask me this, I'm gonna be like, you better go get a tutor.
All right. Take a second, solve this one. Same instructions. B is on, it's this, B, A, B, and C are collinear, B's between them. Take a second and solve it. Let's see what we get. Like I said, the easiest thing to do with these things, guys, draw the picture, start filling in the blanks. What can you guys say right away about B before you do anything? What do you know about point B? It's the what? It's a midpoint, yeah. It has to be the midpoint because notice AB and BC are the same thing. Convenient. So you have x plus x. You have 2x. 32 is 24. And then x is negative 4. And again, is it okay that I have a negative for an x? Because if I substitute in, what's negative 4 plus 16? And what's 12 plus 12? Ding, 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 ding. It's okie dokie. All right. But you also were able to do stuff. Let's see if I have that open still. That's good. That picture. Try this. Same deal. Remember, all the algebra that we've done here really works out to be two-step, pretty quick and painless algebra. The geometry part has always gone back to the, what are you going to do with that value of x once you find it? Is it just solve for x? Is it substitute back in? Things like that. So remember, you do have to read. That's the kicker on a lot of these. So if I look at this one, that is an x minus 5, 3x plus 2. All of that added together has to equal the 6x 23. Combine your like terms. 4x minus 3, 2x minus 23. Oops, sorry, 6x, excuse me. Pick on the little guy. We'll move the 4x, and at the same time, I'm going to add 23. You get 10. Substitute through, and you should work out cleanly. You have what, 32? This would be 5. Just to double check. 60 minus 32. Oh, sorry, 60 minus 23. And that's 37. So yeah, we did it right. You can always double check the math here, guys, by substituting back in. I cannot stress the importance of taking 2 seconds and doing that, okay? Don't forget to bring a calculator tomorrow. After we did all the segment stuff like this, we then jump-started back into these 3 things. And this is where most of you guys messed up on the quiz. Distance, midpoint, and a missing endpoint. And what I want to do is just kind of walk you through again. How do you set that up? How do you work with it to make sure that you remember the differences between solving for each one of those separately? So if we have the ordered pair, let's see, -4 and 3, 2 and -5, right? Yes. And what I want to do is I'm going to say that these are our 2 points, A and B, and we're going to find the distance between. So you could do one of 2 things to find distance formula. You could use the entire distance formula, the whole square root, and write all that out. Or remember how we did it. Find the change horizontally, find the change vertically, square both of those like you're using a right triangle, and just hit some buttons. It's really quick. Or you can write it out. Square root, change in x, quantity squared, change in y, quantity squared. Personally, I think shortcut logic-wise, a little bit cleaner. A little less work. -4 to 2. How far apart are they? 6. So if I do it the shortcut way, that would be 6, and then I square it. 3 and -5, how far apart are they? 8. And I know that I'd have to take the square root of that when I'm done. So let's see, that's 36. What's 36 and 64? What's the square root of 100? 10. So how far apart are they? 10. That's it. Their distance is 10. Now, when you find the midpoint of it, that's when you find the averages, remember. That's when you're adding them together and cutting it in half. That's when you have to be sure that you use that fraction bar in your calculator. So your midpoints, add the two x values together, cut it in half. Add the two y values together, cut it in half. So what's -4 plus 2? What's half of -2? What's half of 2? So what's half of -2? That's it. Then I do the same thing with the y values. 3 and -5. Three and -5 is how much? 4. 3 and -5 is -2. What's half of -2? Make sure you put the negative in it. You forgot the negative after 5. So the midpoint is just a halfway spot between the two numbers. Add them together and cut it in half. The missing endpoint one, though, that's when you would just count the direction. If you're going up or down. Remember that one? After we did it a few times, you guys got really good at it until you had to read the question on the quiz, which you guys did the opposite. So let's see, if we had -4 and 3. So that was this. We'll say our endpoint was M. Where is B then? If that +2 and 5 was the halfway spot, remember you'd have to go just as much further past it to get to the ending spot. So from -4 to 2, you go up or down? How many? What's 6 plus 2? From 3 to -5, you go up or down? How many? So what's 8 less than -5? It's done. That's the differences between these guys. That's all it is. That's the only difference between those. After we did missing endpoints and all that, then we switched to angles. And when we talked about angles, we had, geez, I think there was like 10 different pictured parts of angles that we can look at. Let me show you. We went to angles. We had acute, obtuse, right angle, straight angle, adjacent angles, complementary angles, supplementary angles, linear pair, vertical, actually that congruent too, though. One last. So just kind of talking through these 10 basic diagrams here, what does an acute angle measure? Less than 90. Okay. Acute angles measure less than 90. So if you're going to draw a picture of an acute angle, just draw anything that looks like it's smaller than 90 degrees. Does that work? There you go. If I do the same thing for an obtuse angle, what would that look like?
More than 180.
More than 180?
More than 90.
More than 90. Less than 180. So something like that. Remember, in geometry, we're going to keep all of our angles between 0 and 180. We're not going to go past it. When you draw a right angle, what do you have to do? What's that? 90 degrees, but what do you have to put on the there? That little square, yeah. Whenever you have a right angle, you got to make sure you label it with that. That's all you have to put. And then you know it's a right angle. What do you know about all right angles? They're always how much? 90 degrees. If every right angle is 90 degrees, it means they all have the same measurement. When angles have the same measurement, it means that they're always congruent. Therefore, you can say all right angles are congruent to each other because they're all measured 90. What does a straight angle look like? Yeah. There you go. Pretty easy. What are adjacent angles? Next to each other, what do they have in common? Vertex, very good. The adjacent angles are the ones that have the same vertex. Those are adjacent angles. They have a common vertex. They have a common side. And that's it. What do complementary angles have to do? 90 degrees. Two angles that add to 90. So the easiest thing to do to show a picture of what a complementary angle is to draw a right angle and draw a line through it and label it angles 1 and 2. It doesn't say that they're 45, doesn't say that they're anything. It just shows that there are two smaller angles that are put together to make the 90-degree angle. That's a picture of complementary. What do you think you would do with supplementary? It'd be basically the exact same thing. Now, what you're actually doing is you're using adjacent complementary angles, adjacent supplementary angles. But they need to be adjacent to show that it's supplementary or complementary? No, that's just like number 45 that you were asking about, how we drew them all separately. They don't have to be sharing the same vertex. They don't need to be. In this case, it's just easier sometimes to show it. Again, you just label it, angle 1 and angle 2. Those two add up to form a line. Done. The linear pair, though, has to be adjacent. The linear pair has to be adjacent. That's why it makes a linear pair. Gee, that looks a whole lot like the supplementary one, isn't it? Because aren't linear pairs supplementary? They are. They're just more specific because they are adjacent. And then after that, we talk about vertical. What do vertical angles look like? How are those formed? We worked with them. They weren't difficult. How are vertical angles formed? Yeah.
Isn't it like when they cross over, like draw like an X and then this angle?
I was waiting for
is the same.
Yes, exactly. The vertical angles are formed when two lines intersect. When two lines intersect at one point, you will always have four angles that are created. Of those four angles, only two of them are the same. The angles that are opposite one another, going in opposite directions, are the same, and going back the other way as well. What do those tick marks, those little arches, represent? Congruency. They mean that they're the same. So showing that something is congruent, it's kind of the same thing as what we had there, just by throwing a couple of tick marks in. That's it. That's how you can show something is congruent. So really what I'm getting at here, guys, a lot of the stuff that we've done, the algebra, pretty easy. It's a matter of remembering what things meant in order to get to use the algebra. That's where we have to be careful with. Okay? So let me try an example. Oh, can you do angle addition the same as you would segment addition? What's the only thing that's different? You've got angles instead of segments. That's it. A degree. That's it. That's it. Everything else works the same. Can angles be bisected? Yeah, means the same stuff. You use the same properties. For example, find the measure angle WBA if WBA is 141 plus X, CBW is X plus 29, and the whole angle is 168. What do you think you need to do? You're right. Two smaller chunks equal the whole. put the algebra together. Two smaller parts, 141 and x, and then x and a 29 is 168. What's 141 and 29? 170. And you're back at a two-step algebra problem. Subtract the 170. You get -1. Is it saying that the angle is negative? It's just saying that the value of x is negative. If you substitute back in, what's 141 minus 1? What's 29 minus 1? Do those two add up to equal 168? Yay, math. The idea that you go back and double check it, it only takes a second. It works out really, really nice. Do you agree? Becky? Trying to be nice. One. Okay. Solve that problem, please. Take a second, solve it. Short here, so let's see, this much was 30. So y is 8x. So 8x plus 39. You okay with that? Let's put it together right away. Add the 5, subtract the 8. Hopefully you got 11. Yes? No? All right. What's 8 times 11? What's 88 and 9? 90. Well, 97. 97 and 30 is 127, I believe. And then 12 times 11 is 132. Subtract the 5 and you get dun 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 127. Indeed. What else was messing you up? Remember complimentary, supplementary? What I want you guys to work on tonight is the chapter 1 review. I already posted it online for you. It's page 60, and it's 1 through 31. It looks like it's a lot, but really, most of those questions are real fast. You know, what does this do? What does that do? Solve for x real quick. Things like that. It shouldn't take 15 minutes, 5 tops. Yeah.
calculator, are you gonna collect them?
Yeah, I'll collect that tomorrow. What I like to do a lot of times for geometry is that I assign you guys usually the chapter review the night before the test, because it's just the regular homework then, and it forces you to go through all of the chapters. And you would be surprised. That is the one assignment historically people don't do. And there's a huge correlation by people that don't do the review and how they proceed on a test. Yeah, it's amazing the correlation. So work through those. We'll get that tomorrow. Don't forget calculators and all, and then we'll start some logic stuff on Wednesday. I don't know how crazy we're going to get involved in some of the logic parts in Chapter 2. There's really like 3 or 4 sections of a lot of weird logic things. I might just kind of combine it all over the course of maybe these 3 days or so before we start talking about some algebra proof stuff and going from there. But we'll see how it plays out.
Or